Okay, so here we've got a question with a paving slab. The paving slab is held in equilibrium by this force here holding it up against the action of its weight downwards. And the pivot point is here, the corner of the paving slab. So the whole thing's in equilibrium, which means there's no resultant force acting. Now we know that the mass of the paving slab is 45 kilograms, okay? So 45 kilograms. So the weight is equal to the mass multiplied by the gravitational field strength, which equals 441 newtons. So that's the first thing. Now we've got to work out this force F. Now, if everything's in equilibrium, we know that the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. And we know that from the principle of moments. Now, a moment is a force multiplied by the perpendicular distance from the pivot point. So this force is acting anti-clockwise. So in the anti-clockwise direction, we've got F multiplied by its perpendicular distance from this pivot, which is 0.600. Clockwise, we've got this weight, which is 441, multiplied by a distance. Now this weight is acting at an angle to the slab. It's not acting perpendicular to the slab, it's at a different angle. It's not acting at 90 degrees to the slab, it's acting at some other angle. So that introduces a bit of confusion potentially in this question. So do we need to do some trigonometry and split this weight into two components, one of which will be perpendicular to the slab? Well, the answer is no, we don't. Why not? Well, this weight will be acting halfway along the slab because that'll be the centre of mass because the slab is uniform, we're assuming. And that will be 0.3 meters. So if we were given that distance there, you can see that is not the perpendicular distance from the pivot to this weight. And if we only had that distance there, we'd have to do some kind of trigonometry. However, we're given this distance here. This distance is the perpendicular distance from there to there. So we've got the force and its perpendicular distance from the pivot point. So therefore we can just put that into there. That is the perpendicular distance. We can rearrange then to get 441 times 0.150 divided by 0.6, which is going to give us our answer, which is 110 newtons.